Now let's take a look at section 5.5, which is understanding and solving ratio and proportion problems. You will notice that many business problems are expressed as ratios, and a ratio is just a fraction that's comparing two quantities. I have a note here that we can reduce as needed, so you can reduce it if you need to. So an example of a ratio would be 5 dogs for every 2 cats. Okay? So that is a ratio of 5 to 2. You can write it as written as 5 to 2. So use a colon, and when you read that as 5 to 2. And then when I talked about reducing, so an example of reducing, if you had a ratio of 40 to, let's say, 20, you could reduce it to 2 to 1. You can see this as the same thing as 40 over 20. You could reduce it to 4 over 2, which could then be reduced to 2 over 1, and we would rewrite it as 2 to 1. Now a proportion is just two ratios that are equal. The most important thing about a proportion is that the numerators, so the numbers on top, have to have the same label or same unit, and then the denominators on the bottom, they also have to have the same. So you can see here on the top, the numerators, we've got dollars, denominators, we have pounds. So you could have it written, something written as fractions, and we could do $9, pounds, pounds. Or you could write it as $9 to 2 pounds equals $18 to 4 pounds. So there's two different ways to write a proportion. The steps to solving proportion problems is using cross multiplication. So the first thing that you need to do is assign a letter to represent the unknown. There's going to be one piece of information that you don't know, and so we're going to need to assign a variable to it. Then you need to set up the proportion with one ratio expressed as a fraction on each side of the equal sign. Then you cross multiply and then you solve. So I'm just going to show you how we do this. And I think hopefully for most of you this will come back to you. On a recent trip, a car used 16 gallons of gasoline to travel 350 miles. So 16 gallons goes with 350 miles. At that rate, how many gallons of gasoline would be required to complete a trip of 875 miles? So we are going to set this up. 16 gallons to 350 miles equals how many gallons for 875 miles? So when you cross multiply, you can simply put an X there to help you. We're going to multiply 16 times 875 equals 350 times x. $16 times 875 is 14,000 equals 350x. Divide each side by 350. X equals 40. Now x doesn't just equal 40. We're trying to find how many gallons, so x equals 40 gallons. So we can check our work by making sure that 16 over 350 in fact equals 40 over 875. I just put this in my calculator and I got 0.04571, and when I put this in my calculator I got 0.4571. Done. So now see if you can pause the video, do the your turn problem, and then come back and check your work. Okay, so if Steve earns $87.50 for 7 hours, how much can he expect to earn in a 35-hour week? So keeping in mind that the dollar amount is on top, and he gets $87.50 for 7 hours, and they want to know how much can he earn. So how much money can he make? That's what we're looking for over 35 hours. So we are going to cross multiply. So $87.50 times 35 equals 7 times x. $87.50 times 35 is $3,062.50. Divide each side by 7. X equals $437.50. Of course, we're going to check our work because that's what we do in Chapter 5. So we are going to make sure $87.50 divided by 7 equals $437.50 divided by 35. So I got 12.5 over here, 12.5 over here, and we're done. That's how easy it is to solve proportion problems. Your homework is due next Wednesday. We don't have class on Monday. The homework is pages 140 to 144, numbers 2 to 18, the evens, 21, 23, 29, and 30. See you in class.